Okay, so in 1324, business algebra, I believe the last thing that we did was we had done 6.1 and 6.2, but I had left the last two problems for us to do when we got back. Well, we're never coming back, but we can still do these problems. Now the problems say find the equation of the parabola that goes through these three given points. So we know that if there are 2 points, that we can create a line between them. If there are 3 points, there is a unique parabola or quadratic that goes through these equations, or through the points. Now, how do we do that? Well, the first thing to understand is that what is the equation of a quadratic? Generally, it's ax squared plus bx plus c. A, b, and c are usually, though, numbers and not a, b, or c. Now, how can we use that through the points 2, 4, -1, 1, and -2, 5? Well, let's remember what an ordered pair is. It's a set of x and y coordinates. So for this first point, 2, 4, this is the x and this is the y. Now if we look over at our equation also has x's and y's. So we need to substitute these two in, and then we're going to get a system of equations in terms of a, b, and c. So we've got 4 equals a times 2 squared plus b times 2 plus c. Or, that's the equation, 4 equals 2 squared is 4, so 4a plus 2b plus c. That is our first equation. Now, how many points do we have? 3. So we are going to repeat this with -1, 1 and -2, 5. So again, this is x and y. We'll do -1, 1 next. You'll get 1 equals a times -1 squared plus b times -1 plus c, which means 1 is equal to -1 squared is just 1, so that's going to be a. -1 times b is minus b plus c. So this is equation 2. And what's equation 3? Doing the same thing with -2, 5. We will have 5 equals a times -2 squared plus b times -2 plus c, which means 5 will equal 4a, because -2 squared is 4, minus 2b plus c. Now, one thing to note for this kind of problem, every single time you do it, the c is not affected in any of these equations by what you plugged in, which is going to allow us to very easily cancel out the c's in 2 different sets of equations and get us just down to a and b in the whatever sets of combinations we make. So the first thing I'm going to do is I'm going to write all of the equations over here. So 1 equals a minus b plus c was equation 2, and 5 equals 4a minus 2b plus c. Then I'm going to decide I'm going to cancel c's out, and to do that I'm going to multiply equation 2 by -1. So instead of 1 equals a minus b plus c, I'm going to get -1 equals -a plus b minus c. Now I can use this minus c to combine it with equation 3, and use the minus c to combine it with equation 1. So let's combine it with equation 1 first. 4 equals 4a plus 2b plus c. Using elimination, what happens when I combine these two? I get 3 equals 3a plus 3b, and the c's cancel. Now, all of these are what? A multiple of 3. So I can divide all of them by 3 to get 1 equals a plus b. A nice, easy equation to work with, and I'm going to call this equation 4. Now I'm going to take that same thing, negative 1 equals negative a plus b minus c, and combine it with my equation 3, which is 5 equals 4a minus 2b plus c. Now when I combine these, what I'm going to get is 4 equals 3a, it's like minus b. Now that's not going to reduce. So, but do I have two? I do have two equations though now, and just in terms of a and b, so I can use these two and combine them together. So let me bring 5 down. Bring my 4 equals 3a minus b equation down. And let's see what happens when I combine these two by elimination. Now, lucky for us, our b's already match up perfectly. If they didn't, you may have to multiply one by something. We get 5 equals 4a, and then the b's cancel, which means what is a? Divide both sides by 4. You get a equals 5/4. Okay, so how does that help us? Well, once I have a, I've got these two equations with just a and b, I can plug back in for b. I think the 1 equals a plus b equation is easier. So we have, again, equation 4 is 1 equals a plus b, but now we know what a is, so 1 equals 5/4 plus b. Subtract the 5/4. Now 1 is 4 over 4, minus 5 over 4 makes b negative 1/4. Now that I've got both of these, I can plug in both of them to find c. Now equation 2 was 1 equals a minus b plus c. So let's plug in. A is 5/4. B is minus negative 1/4 plus c. Now minus and negative is really adding, so 5/4 plus 1/4 is 6/4 plus c. We can reduce that to 3/2. And subtract the 3/2. We get negative 1/2 equals c. Now, how do I put my answer? Again, this was going back to the equation y equals ax squared plus bx plus c. So I need to take my a, b, and c and put them in the parabola. So we get y equals 5/4 was a, so 5/4 x squared minus 1/4 x minus 1/2. So here's my a, b, and c in equation form, and that is the equation of my parabola. If I want to check if it works, I can plug in a number. Let's say we plug in the 2, 4 from the beginning. 2 squared is 4. Now 5 divided by 4 times 4 is just going to be 5. So what do we get? This is 5/4 times 4 minus 2 times 1/4 is 1/2. So 5/4 times 4 is just 5. So 5 minus 1/2 minus 1/2. Well, 2/2 is just a whole, which is 4. Did I get the y value from my original point? Yes, it was supposed to be 2, 4. You can check all the points if you want to, but that is how this kind of problem goes. This will also apply to number 6 as well. I hope this helped. That would be the end of 6.2, and so the next thing we do will be something new. See you next time.